Hello, grade 9. Our lesson today is periodic trends. So our question today is, how can you use the periodic table to predict an element's properties? So to answer this question, let's start the lesson. So the new vocab for this lesson are ionization energy, octet rule, electronegativity. As we know that principal energy level is the major energy level of an atom. Now, atomic radius. First, let's start with the first periodic trend, which is the atomic radius. Many properties of the elements tend to change in a predictable way, known as a trend. So, what do we mean of periodic trend? Trend means that the elements are tend to change their properties in a predictable way in the periodic table. We call this as a trend. As you move across a period or down a group, atomic size is one such periodic trend. So the size of atoms are influenced by electron configuration. So as you move across a period or down on the group, so as you go, for example, to the right of the period, or as you go down in the same group, the atomic size is one such as a periodic trend, because the atomic size will change. So that's why we call this as a periodic trend. The sizes of atoms are influenced by the electron configuration. Why the size of the atoms will change? Because according to the electron configuration for each atom. So recall that the electron cloud surrounding a nucleus does not have a clearly defined edge. As we said that we have, according each nucleus, we have a cloud with not which is not have a defined edge. Okay, the outer element of an electron cloud is defined as the spherical surface within such as which there is a 90% probability of finding the electrons. As we said before that this is the cloud around this is the nucleus, and this is the cloud around it. As these dots are closer to each other, means there is a more probability for the electrons to be in. So this circle means inside this circle we have 90% probability to find the electrons inside it. Okay, so this circle, it's not the edge of the atom, no, but it's the most probability for the electron to be in. However, the surface does not exist in a physical way. As I said, as the outer surface of a golf ball does, atomic size is defined by how closely an atom lies to a neighboring atom, because the nature of the neighboring atom can vary from one substance to another. The size of the atom itself also tends to vary somewhat from substance to substance. Now, for metals such as sodium, for example, the atomic radius is defined as half the distance between adjacent nuclei in a crystal of the atom of the element, as showing in the figure 11. So, for metals, how we can define the radius, the atomic radius? It's the half distance between adjacent nuclei in a crystal of the atom of the element. For elements that commonly occur as molecules, such as non-metals, so the atomic radius, so for molecules such as many non-metal, there are molecules, the atomic radius is defined as half the distance between nuclei of identical atoms that are chemically bonded together. The atomic radius of a non-metal diatomic hydrogen molecule H2 is shown in figure 11. So this, for example, we have for metal two adjacent atoms. So the radius is defined as the half the distance between nickel for each, for the two atoms. For example, this is the distance from the adjacent nuclei, which is 372 pm. The half the distance is 186. So this is the radius. The radius of a metal is one half the distance between two adjacent atoms in the crystal. And this is the, for example, the for molecule, as we know, molecule means like O2, H2, I2, okay, and they are non-metal, as we know. So this is for hydrogen, H2, okay. So this is the distance between the two nuclei, which is 74. Half the distance is 37. So the radius of non-metal atom is often determined from a molecule of two identical atoms. Okay. So again, for metal, the atomic radius is defined as half the distance between adjacent nuclei in a crystal of the element. For non-metal, for elements that commonly occur as molecules, such as many non-metal, as I said, that like H2, O2, the atomic radius is defined as the half distance between the nuclei of identical atoms that are chemically bonded together. So they are bonded together like this. Okay.